My name is Drew Spencer, and I'm a marketing analyst. And some of you sitting here in this classroom are probably wondering when, if ever, you might use some of this math, wondering what this math might be good for. Some of the higher level math that you'll be learning in school, in fact, has a lot of everyday applications. And one of those, if you get into the field of marketing, or if you get into business planning, is store locations. If you're in marketing and you have an event and you want to invite people who you know will come, you need to invite people who you know are already nearby, because people are not going to drive a long way for an event, but people will drive a small way for an event. If you have a growing urban area, or if you have customer data that shows people are driving to your store from greater and greater distances, then you might want to put a new store somewhere else. Well, you have to decide on 2 locations where you might be able to afford to put in a store, and you have to figure out which are closest to the people that you know will be customers, which are closest to the new development, or which are closest to the people that are already coming but live further away. There's 2 ways to get that answer. One is the Pythagorean Theorem, and the other is trigonometry. And you can pick. Why the Pythagorean Theorem? Because the hypotenuse of a right triangle is the shortest distance between 2 points. And why trigonometry? Well, that's because the Earth is a circle. And being a circle, the distance between any 2 points is the perimeter of that circle, or a portion, a line segment of the circumference of that circle. Now, the Earth is not a perfect circle, nor is it perfectly flat. The Pythagorean Theorem is one-dimensional. It assumes that you've got a flat area. The Earth itself is what's called an oblate spheroid. It's not perfectly round because it bulges at the equators. But if you're doing all your calculations with the same method, then all your calculations have the same caveat. So they have all the same concerns, all the same discrepancies in how you calculate, so they're perfectly good for comparison purposes. One calculation has all the same concerns or discrepancies or caveats that the other one does, so you can make a valid and perfectly accurate comparison between the 2. But you need data. The first thing you need is people. You need to know who, you need to know a zip code, and I'll get to that in a minute, and you need to know a coordinate system, a latitude and longitude. The whole world has been mapped on a coordinate system. It's called latitude and longitude. Just like your graph paper with x and y coordinates, we have latitudes and longitudes that tell us where things are on a map. So if I have one set of latitude and longitudes for a person and another set for a store, I have 2 xy points on a map, and I can calculate the distance. We'll start with me, you, and her. I am at 76013 for a zip code. You are at 75010 for a zip code. And her, she, is at 77014 for a zip code. And I have corresponding latitudes and longitudes for each one of those people. It tells me where they are on a map. I have my first point on the map. Now I need stores. I need the same information for the stores. I need my store number 1, my store number 3. They're at different zip codes and different latitude and longitudes. I now know where both people are and stores are, and I have everything to put them as points on a map. But that's 24 calculations. That's 3 people and 8 stores. If I have thousands of people and hundreds of stores, that's a lot of calculations. I only really care about people that are reasonably close. They're in neighboring zip codes. And the Postal Service has a name for that. It's called SCF, Sectional Center Facility. The first 3 characters of a zip code are the SCF, and anybody with the same SCF is somewhat, sort of, reasonably close to each other. They're in neighboring zip codes. So all of the DFW side of the Metroplex is 750. All of the Fort Worth is 76. And that's how the Postal Service has classified neighboring zip codes for us. One more thing. I've now got my points, I've now got my people, I've now got my stores, but my distances are going to come out in latitude and longitude differences. I want something that looks readable or reasonable. I want coefficients to turn those values, differences expressed in latitude and longitude, into miles or kilometers. And we'll see that in a moment. The first thing is a right triangle. And although this looks like code, it is code, it's actually very similar to what you learned in class. It's the square root of the difference of latitudes between stores and peoples squared plus the difference in store and people longitude squared. Just like what you learned in class. And I've got it in kilometers first and miles second. I have a factor here, 69.172, which is an estimate of a coefficient for turning differences in latitude and longitudes into miles. I then multiply that by a factor that turns miles into kilometers, and I have a calculation in kilometers. I use this calculation down here, 69.172, to turn the distance just into miles. That is an estimate, that coefficient is an estimate for the United States, for the continental United States. As you move towards the poles, towards the equator, that coefficient varies because the shape of the Earth varies. If I use trigonometry, I can use inverse cosines, sines, and cosines, and pi, the factor that relates the radius to the circumference of a circle, to do the same thing. Why would I use trigonometry? One reason you might want to use trigonometry is larger and larger distances. If any of you have pilots in your family, then you'll know that they don't fly exactly between 2 points from Miami to Seattle. They fly in an upward, I believe, upward leaning arc, because that arc is in fact slightly shorter. That's because the world is in fact a circle, and you want to follow that perimeter of that circle as best you can. So for larger distances, you can get a slightly more accurate calculation, but remember, it's not driving distance. If you calculate all your distances this way, then they're equal for comparison. But don't mix your calculations. Don't use driving distances, don't use trigonometry, and don't use Pythagorean Theorem altogether. Pick one and use one and compare all your points with one, because they'll all have all the same caveats that way and be equal for comparison. I use a factor for converting from the line segment on that circle into kilometers. That factor is 63171, and I use another factor, 6371, times the conversion from kilometers into miles to get the distance in miles. And that gives me the distance along that line segment of a circle that I can use to determine how close someone is to a store. I hope you find that useful someday, maybe when you're 25, 35, or 45 and sitting in a meeting and someone says we need to put in a new store, and you remember that you have the answer. It's your math class that you had here at Flower Mound High School. Thank you very much.